Today, I will present three corroborating evidence suggesting that the world could cross the dangerous 2 degrees Celsius global average temperature anomaly as early as 2026 or 2027. Reaching this threshold would expose all of us to extreme and prolonged climate events such as heat waves, fires, hyperstorms, and flash floods on a regular basis. In 2016, 175 countries signed the Paris Agreement, pledging to keep global warming below 2 degrees Celsius. The IPCC warns that crossing this limit will make life, to most of us, a constant struggle for survival. Hello, I'm Roland from the Philippines. I'm not a climate scientist, but I hold a master's degree in computer science, graduated physics, and most importantly, I discovered critical information from publicly available climate data. These data sets strongly indicate we may reach 2 degrees Celsius in barely 2 years, much sooner than the 10 to 20 years projections often cited by climate scientists and their models. In this presentation, I will show three crucial evidence that point toward a possible 2 degrees Celsius breach during the next El Niño event in 2026 or 2027. All data come from trusted scientific sources and have been cross-checked using AI platforms shown in the video. Let's begin. Evidence number one. Global temperature rise is accelerating exponentially. The global temperature anomaly chart from Our World in Data shows an exponential rise in average temperatures since pre-industrial times in 1850. In portrait view, the chart highlights a critical threshold in 2027. Beyond this year, the temperature trajectory shoots sharply upward. This suggests extreme temperatures after 2027. In landscape view, more useful for detailed analysis, the trend reveals a clear pattern. Every 0.5 degrees Celsius or half a degree step is happening dramatically faster than the previous one. From 1850 to 1980, 0 to 0.5 degrees Celsius in 130 years. From 1980 to 2015, another 0.5 degrees Celsius to 1 degree Celsius in 35 years. From 2015 to 2024, from 1 degree Celsius to 1.5 degrees Celsius in just 9 years. The sequence is 130 years, 35 years, then 9 years. This sequence of years strongly suggests that the next half a degree Celsius increase, taking us from 1.5 degrees Celsius to 2 degrees Celsius, could occur in about 2 to 3 years. This points directly to mid-2026. This conclusion is further supported by the continued rapid rise of atmospheric carbon dioxide, currently around 430 parts per million. The CO2 growth or carbon dioxide growth curve is itself accelerating, now increasing by 3.75 parts per million per year. Thus, the temperature sequence 130, 35, 9, 2.3 years suggests a sharp temperature spike between 2026 and 2027. Evidence number two. Climate sensitivity or less carbon dioxide required for each additional half a degree Celsius of warming. Using the long-term carbon dioxide record from Mauna Loa, Hawaii, we can estimate how much carbon dioxide increase was associated with each major 0.5 degree Celsius or half a degree Celsius temperature jump. 60 parts per million carbon dioxide increase from 280 to 340 parts per million correspond to the first 0.5 degrees Celsius rise from 1850 to 1980. Another 60 parts per million increase, 340 to 400 parts per million, caused the next 0.5 Celsius rise from 1980 to 2015. The latest 0.5 degrees Celsius rise to 1.5 degrees Celsius by 2024 occurred with only a 20 parts per million carbon dioxide increase, from 400 to 420 parts per million. This pattern clearly shows that climate sensitivity to carbon dioxide is increasing. It now takes much smaller carbon dioxide increase to produce the same warming. Why? Because warming is no longer driven by carbon dioxide alone. Multiple positive feedback loops have been triggered. Arctic sea ice loss and reduced albedo, permafrost thaw releasing methane, wildfire soot darkening snow and ice, warmer oceans releasing stored heat. These tipping elements add warming on top of human emissions. This means even if fossil fuel emissions stopped immediately, temperatures would still rise exponentially. Given the pattern 60-60-20 parts per million, it is logical to expect the next 0.5 degrees Celsius rise to 2 degrees Celsius could happen within just another 20 parts per million carbon dioxide increase, from 420 parts per million in 2024 to about 440 parts per million by mid-2026 or 2027. Both ChatGPT and Perplexity AI estimated over a 60% chance of exceeding 2 degrees Celsius once carbon dioxide reaches 440 parts per million. If there is a 60% chance a flash flood from an incoming storm will wash away your home, do you ignore it and sleep well instead? Or do you evacuate now? Likewise, we cannot ignore a 60% chance of reaching 2 degrees Celsius by 2026 or 2027. Evidence number 3. Loss of reflective ice greatly amplifies warming, or albedo collapse. Raising Earth's global average temperature by just 1 degree Celsius required around 260 zetajoules of heat. This enormous amount of energy trapped by greenhouse gas doesn't go away, but has melted large portions of the polar ice cap, which traditionally reflect sunlight and cool the Earth. With ice melting, dark ocean surfaces absorb much more heat, a positive feedback loop accelerating warming independently of CO2 emissions. Millions of square kilometers of Arctic sea ice have turned into dark ocean water, drastically reducing the Earth's albedo reflectivity. AI estimates this albedo loss adds the warming force equivalent to about 140 parts per million of carbon dioxide. Add this to today's atmospheric CO2, which is 430 parts per million. 430 plus 140 equals 570 parts per million of carbon dioxide equivalent warming. Renowned climate scientist James Hansen concluded that doubling pre-industrial carbon dioxide from 280 parts per million to 560 parts per million commits Earth to nearly 4.8 degrees centigrade of warming. Under this framework, Earth has effectively already passed the 560 parts per million threshold. We have effectively surpassed this threshold due to loss of ice reflectivity alone, making 2 degrees Celsius warming by 2026 or 2027 and subsequent quick increase to 3 to 4 degrees Celsius to be expected. Climate scientists and we simply can't understand exponential global warming, or simply because we are accustomed to linear growth. We think although there's climate change, it progresses gradually. Why would climate suddenly change and become unbearable, inhabitable? Temperature rise appears to be moving slowly for a very long time until it reaches a critical point and then explodes. That's exponential global warming. That's happening very soon.